Okay, great. Thank you so much for the introduction, Doran, and thanks to everyone for taking the time. So this is joint work with Luna Bellani, Stefano Giolotto, and Nico Pestel. And it's part of a larger research agenda that Nico and I have been looking into, which is the effects of air pollution on economic outcomes or the effects of air pollution on people's decision-making. And so the motivation for why we're looking into this is that there is obviously a lot of research out there showing that poor air quality, as in exposure to air pollution, has all sorts of negative impacts on people. So it can affect people's health, it can affect people's well-being, it can also affect their cognitive functioning. So the human brain, when it's exposed to high levels of air pollution, processes information differently and works slightly differently. And the big question is, do those channels then have also knock-on effects on decision-making? Okay, so if people are exposed to high air pollution, do they systematically differ in the way they make decisions relative to the same people being exposed to lower air pollution? And there are a number of plausible channels. When air pollution affects health, people can be affected through things like fatigue or stress, anger, anxiety. And there has been quite a bit of evidence in the literature on that. So I'm showing you here a few pictures of areas where this question has been studied, as in, does exposure to high air pollution affect the decision-making in high-stakes decisions? Okay, so there is, for example, some studies on baseball referees, and it's been shown that when the air pollution levels in the stadium are higher, the same referee makes more mistakes in their decisions. Or similar results, even though contested, but have been shown for judges, that judges in, for example, bail decisions decide differently on days with high versus low air pollution. Or there is work on stock traders, where you can obviously very clearly measure what the level of air pollution was at a particular point in time, and how risky the transactions were at the time when they were exposed to air pollution. Or another example is Nico has a paper where they look at chess tournaments, and they measured the pollution levels in different rooms at chess tournaments, and then compared the moves of those chess players to those that a supercomputer would choose. And they show that on days or even at times during the same day when the air pollution level is high, that people make make worse moves, as in moves that a supercomputer would think of as inferior. Now, these are all interesting bits of evidence, but what they all have in common is that they're based on very particular groups of the population, particular segments. And what we were missing is any study that looks at the population at large. Okay, most of us are neither judges nor, well, there may be some chess players among us, but these are obviously arguably very specific parts of the population. So studying then how air pollution affects decisions in the population at large is actually not easy, because of the requirements in terms of data. Okay, so pollution data, air pollution measures of fine particulate matter or ozone are available everywhere almost, and at a very fine-grained geographic level. But it's hard to find good data on people's decision-making. Okay, so we obviously see in surveys that people make decisions, but then we cannot necessarily match that decision to the level of pollution they were exposed to on the day when they made the decision. So we had this lingering in our head for a good while until we came up with an idea of looking at a particular decision that actually a lot of people make on the same day, but in different locations. And therefore, people are differentially exposed to air pollution. And that is elections. So an election is a decision that many people make on the same day. And you typically, you know, this is almost representative of the population at large. But obviously, in most countries, people, you know, have different polling stations in different locations, and therefore, the people who vote on one polling station are exposed to a different level of air pollution than on another. So that's the basic idea. Right? There is obviously some challenges that we need to think about. You know, why do some people live in areas with higher levels of pollution to begin with? What happens if you are like me? So this is a picture actually of me posting my ballot paper, as you can clearly see, from Ireland to Germany. What do we do with male voters and so on? So there's certainly a good few questions that we need to answer in order to make a convincing case. But I'm hoping we can convince you that there is actually an effect to be seen. So as Doran said, we're going to use county level data from 65 elections in Germany. So we have 5 federal and 60 state elections. And in Germany, state elections are also very important because a lot of important decisions, for example, about budgets, about education, about the health system, are made at the state level. So we're looking at those in total a little bit over 400 counties for over the period of 2000 to 2018, because that's the period in which we have actual pollution levels. Now, to identify a causal effect of air pollution exposure on people's behavior in elections, what we do is we exploit variation in air pollution levels within counties across election dates. Okay, so we compare pollution levels and then especially election results within the same county across different election dates. So the idea behind this is that we isolate small idiosyncratic variation in air pollution across election dates. So the underlying thought experiment here is that obviously cities or places in the countryside have on average different levels of air pollution. And what we are exploiting here is purely that relative to what the air pollution levels would be on a typical, let's say, Sunday in September, which is typically when elections take place in Germany, there are some places where on that particular day, the pollution happens to be a little bit higher or a little bit lower than what it normally is. That's the type of variation that we're exploiting. Now, when we do this, there are obviously 2 types of behavioral effects one could think of. One would be a very deliberate choice effect, whereby people observe there is a high level of pollution, and therefore they would, for example, punish the current government. And the other one is an unconscious effect, which is most of us don't even observe fluctuations in pollution, or they don't have a good sense for it. Yet it affects how our body works, how we feel, how we process information, and that may have an effect on decision making. And clearly, with the variation that we're exploiting here, what we have in mind is this unconscious effect on behavior. Okay? The deliberate choice, as in people deliberately changing their voting behavior in response to high air pollution because they feel this is too much, is obviously a very interesting and important question, but we would not be aware of a good research design to answer that question. So for the moment, what we're doing is we're using this research design, and it allows us to get predominantly at this unconscious change in behavior. Now, the main outcome that we are looking at is the vote share of the current incumbent parties. So these are the parties that are in the federal or state government at the time of the election. Okay, so we recently had elections in Germany. And so if I look at that particular election, the incumbent would have been the CDU, the Conservatives, that it's Merkel's party, and their then junior partner, the Social Democrats. Okay, these would have been the incumbent. Now, there are good reasons to look at the vote share of the incumbent here, because the effects that we could potentially see can be reconciled with certain behavioral effects. So one is that there is research showing from the lab that if people are exposed to higher air pollution, they become more risk averse. Don't ask me what the exact neurological processes are behind that, but this seems to be an established finding. Now, if support for the incumbent is considered the less risky option, we could think that the effect could be positive. You're exposed to more pollution, that makes you more risk averse, and you're more likely to vote for the incumbent parties. On the other hand, there could be what's called mood effects. If you are exposed to high air pollution, that puts you in a bad mood, and you may be angry with the current government and less likely to vote for the current government. So it's an empirical question, which of these effects dominates. This is also not an exhaustive list of the potential effects, but there are at least very good reasons to believe that that's an outcome that's worth studying. Now, to preview the main findings, what we do find is a very clear negative effect of air pollution on voting for the incumbent. Okay, so if air pollution is higher, people are less likely to vote for the incumbent relative to, in the same county, air pollution being lower. And what we also see is then obviously those votes must go somewhere else, and they mainly go to established opposition parties. So parties that are also regularly represented in German federal and regional parliaments. Now you may say, okay, this all sounds interesting, but it also sounds maybe a bit far-fetched, or it sounds like something you've uncovered some statistical fluke. And we're very, very well aware of such criticisms. And what we do to counter that is we look at two representative surveys where we know people's interview date and where they took the interview. And we find pretty much the same results in those representative surveys when people are asked, what is your party preference, or how much do you approve of the current government versus the opposition? We also then use the survey data to look at some of the mechanisms, and I'll come to that at a later stage. Now, we make three contributions with this work to the literature. The first and foremost, we see this as contributing to the literature in behavioral economics and behavioral science on the role of so-called incidental factors on high stakes decisions. Okay, so it's been shown over and over again that factors that actually have nothing to do with the decision at hand, such as, I don't know, the weather, whether a football team won, or anything else that simply changes your mood, should not affect how judges rule, important decisions consumers make, and so on. But yet there is research showing that they do. And pollution is obviously one important incidental factor. It's also one incidental factor that can possibly be manipulated by policy. And that's what the whole summit in Glasgow these days, I mean, part of it is about. So that's the first contribution. The second contribution is there is obviously a large literature these days showing that there is economic and social effects of poor air quality. Okay, so you see effects in the education system, you see effects on worker productivity, and we are one of the first papers to show that there is also an effect on political outcomes. The third literature that we're contributing to is a fairly large one in political science. It's quite contested in this literature whether voters are considered to be 100% rational or 100% irrational. They're probably neither. They're probably mostly rational, but they may also be affected through their emotions and something to some degree. And we show that, or our work suggests that pollution is one of those factors. Okay, this is not to say voters are irrational, but it's just to say, to some extent, their behavior can be affected by external factors. Now, this is the one slide biology summary. So how does air pollution affect a person's body and mind? There are multiple channels. Okay, so first of all, the human organism is affected by it through inflammatory responses, through oxidative stress in various parts of the body. And those in turn can lead to illnesses, can lead to fatigue, can lead to negative emotions. However, what has also been shown by neuroscientists is that the brain works also differently when people are exposed to high air pollution. Okay, so people process information differently. They're typically slower in processing information. Their memory works differently. So this is also one of the main effects of pollution on the human body. To what extent that then affects decision making and which of these channels dominates there, well, that's obviously still an open question in the literature, and there are many people working on this, trying to fill those gaps here. Okay, so in terms of data, what we use is we use election data at the county level, and we look at 3 and actually 4 main outcomes. And one outcome that is not listed here is turnout, so election turnout. The other outcomes are the vote share of the incumbent parties in the given election. So those parties that were in government up until the election day. We also look at established opposition parties. So these are parties that are regularly represented in the German federal parliament. And then we have another aggregate that are just smaller parties that are not typically represented in the German parliament. One exception in that, to some extent, is the AfD, which has been in the parliament since 2017 and seems to now have established itself. But we still, because we look at mainly the time from 2000 to 2018, during that time they weren't really established yet. Now we measure air pollution through a measure that's called PM10. So that's fine particulate matter of a size that's less than 10 micrograms per cubic meter. There are different types or different measurements for air pollution. This is a very common one that's used in the literature. And so if you want to know more details about it, I can provide them, but for the moment, for most audiences, that's just the standard one that we observe in the literature. Now, if I hear identification is unclear, well, that's what we're going to talk about in a couple of minutes. And if then it's still unclear, then we can talk further. So that was referring to a message that was just in the chat. Okay, so the summary statistics here, there is just one thing that I want to point out, which is obviously we have, when it comes to measuring air pollution, we don't have a good feel for it. It's not like temperature or so, where we know what a 2 centigrade increase in temperature, we have a feel for it. With air pollution, we don't. What we then consider to benchmark it is the within standard deviation. So that's the standard deviation in the level of air pollution within the same county across election dates. And that's around 0.5. Right? And so I will use this over and over again, this within standard deviation. Just think about it as the typical fluctuation I will use this to benchmark the effect sizes. Now, just to give you an impression of the overall level of variation that we have in our data. So this is the level of PM10 of the concentration of fine particulate matter on election days in different counties. So these are the counties with the lowest average level of air pollution over that entire sample period. These are the ones with the highest, and you can clearly see, yeah, their average is obviously larger, but there is a huge overlap between those counties. Okay, so it's more that within county types there is a huge fluctuation, but actually the difference in average from the highest polluted places in Germany to the lowest is actually not that big. Then what we're exploiting is the variation within a county. So here is the example of the city of Munich. And these are all the elections that are in our sample. And you can see that the pollution levels, even though those are mainly in September on Sundays, they vary quite a lot. And that's the type of pollution that we are exploiting. Okay. Now, the baseline regression model that we're using to uncover that effect is the following. So we regress the election outcomes, Y, on the level of PM10, so particular concentration of particulate matter, on election day in County I. We control for a bunch of time-varying county characteristics. So this is mainly economic and demographic variables. And then we have county fixed effects and election date fixed effects. Okay. So the identification assumption here is that the fluctuations in the level of air pollution within a county across election dates are as good as random. Right? That's what we need in order to interpret this effect beta, this estimate, as causal. And that, as Richard writes here in the chat, is obviously challenging for a number of reasons. Okay? One is that you could have local economic shocks that affect both the level of pollution and affect also the voting outcomes. Okay, you can think about, I don't know, a factory closes, people are angry because of that and change their voting patterns. And at the same time, the level of pollution is reduced because the factory no longer pollutes the air. Or you could think about weather shocks, or you could think about regional trends, or weather shocks, regional trends, or political shocks. Okay? These are omitted variables that we may or may not capture with those control variables. Okay? So we need to think carefully what to do about them. Okay? The other challenge here is mail voting, which obviously presents an interesting challenge econometrically, because if I vote by mail, then I'm obviously exposed to a different level of air pollution compared to me voting on election day at the ballot box or in the polling station. Okay? And so we had to think quite a bit about how to conceptualize this and what it means for our estimation. Now, here's what we do in order to address some of these comments. So there's also the question, how can you tell air pollution apart from genuine dislike of the incumbent? Good question. Okay, so let's think what gets already captured. So if the incumbent is generally disliked across Germany, that's captured here by those election date fixed effects. If you have a county that always votes more against the incumbent than another, on average, that's captured by those county fixed effects. Okay? And also importantly, we're obviously only then using very small still big enough, but you know, idiosyncratic variation within the same county across election dates. Now that may not convince you yet, right? But the main thing we're doing is we're doing placebo tests based on placebo election dates. Okay, so the idea is I take the actual voting outcome, and instead of relating it to pollution levels on the actual election day, I take pollution levels on days after the election. Right? And if it was really a bias, then we should see the same effects no matter what pollution level I choose. And if not, we should definitely see a very clear difference in the effects. And I'll show you the graphs, which I believe are quite convincing. Now, the other thing we do to address mail voting is we show that this is akin to a measurement error problem, and we show that under reasonable assumptions, it results in an attenuation bias, as in the estimates in absolute value are smaller than they would be if everyone voted on the actual election day in the polling station. So here are the main results. So in the first panel, panel A, you see the results without controls. The only thing we do here is we condition on county and election date fixed effects. In the second panel, we condition also on weather variables. In the first three columns, we also condition on turnout. And that's that. Okay, so what's interesting, first of all, before I tell you what the magnitude here means, is that the controlling for weather, controlling, for example, also for ozone levels, does not make any big difference to the estimates. Okay, they're very much similar. They're a little bit bigger in panel B, but not very much so. Okay, so that's one way to say, well, this corroborates the assumption that pollution levels are as good as random. It's not a proof, but it's one piece of evidence that we can bring. Okay, we also have in the paper balancing checks where we use the same variation to try and predict economic and demographic data, and it always comes out insignificant. So there is no systematic relation between pollution and these variables. Okay, then let's look at the effect size. Okay. So here we have an increase of that concentration, which is measured in 10 micrograms. So an increase in the concentration of PM10 by 10 micrograms reduces the vote share of the incumbent by about 2 percentage points. Okay, so here the mean is 48%. And so, here you would have a 2 percentage point decrease. Is this a big effect? We should probably to think about it more in terms of what is the usual degree of fluctuation, half this effect. So for a 1 within standard deviation increase in the level of PM10, we would see that the vote share of the incumbent in that election drops by around 1 percentage point. Okay, so it's not that it decides each and every election, but it's not a trivial effect either. Okay? And what we see is that most of that difference goes to established opposition parties. Okay, so they are the ones who gain the most. We have been asked multiple times to look at other parties. That's why we do. It's a bit harder to see to think about, well, why are other parties losing out as well? The effect is relatively small, but that's that I have to honestly say, this is a bit harder to find a good story why this is the case. Whereas then we looked at turnouts, and there we don't find any significant effect. And that's not further surprising, because the pollution fluctuation that we're using here is not like in some middle income countries, or it's not like in China where in large cities you have huge amounts of pollution where you can actually see and feel it. And therefore, you say, oh, today there's a high level of pollution that may influence people's decision to go out to vote. The levels of pollution and the fluctuations that we observe in Germany typically are of a magnitude that you don't actually notice them. They're not salient, and therefore it's also plausible that they don't significantly affect turnout. So it's not like rainfall or so that has been shown to do that. Now, to further benchmark this effect, so one standard deviation of increase in the level of air pollution, as I said, reduces the support for the incumbent by about 1 percentage point. How big is this effect? Okay. Now, this graph here shows you just for federal elections what the losses or gains of the incumbent parties are relative to the previous election. Okay? So interestingly, this tends to have increased, and I did not plot here the 2021 election where that would even be, where I would have to probably use a log scale for that. But one interesting election, for example, as it was quite important for what happened afterwards, was the one in 2005 when Angela Merkel was elected. Okay, so before that, we had a government of the Social Democrats and the Greens, and they, for example, in that election lost about 5 percentage points. Okay, and then Merkel won the election and entered a coalition with the Liberals subsequently. Okay, and so there we have a 5 percentage point drop of the incumbent. When you look at this, in terms of what our effect size is, it shows that this effect is economically or socially quite significant. What I'm not saying here is that that the pollution explains 20% of the drop in the incumbent vote share, because obviously that would be an extrapolation from a small degree of variation to variation across places within the country. That would not be that comparison or that decomposition would not necessarily make sense, and we'd have to do more to do that. But that's not the aim really here. Okay. So then, again, to address some of those comments in how can you ensure that your results are not driven by systematic variation in air pollution across places, in pollution over time, or disliked by the government, or technological shocks, or whatever other omitted variable you can think of. And what we do is we run placebo tests. So what we do is, here, where you see that vertical line and where you can see election, that's the effect that we get when we use the pollution level on the election day. And so to the left of it, we have, instead of having the pollution level on the election day, we have the pollution level 1 day before the election, in another model, the pollution level 2 days before, in another model 3 days before, and so on. So each of those is the result of a separate regression of the true voting result on pollution levels on several days before or after the election. And what you see is quite interesting. So on days before the election, when it's plausible that your pollution exposure even a day before might affect your mood, and people make their decisions maybe a few days before. So it's plausible that it affects that it might still affect you a few days before. So there we see significant results that go exactly in the same direction as the effect when we use pollution levels on the election day. Here, the exact same when we look at the established opposition parties. And then once we use pollution levels after the actual election, that should not have any plausible effect on voting outcomes on that election day, we see that they hover around 0. Okay, so here we see some that are statistically significant, but very small and negative, but they are nowhere near the effects that we see here. And so in the recent version of the paper, we did this even more systematically. So we used placebo election dates, basically, 100 days before, 100 days after, plotted the entire distribution. And besides those 10 days before, you don't see any effect anywhere. Okay, so this seems to, or all the other placebo estimates are very much around the zero mark, around the no effect mark. Okay? So that's what we take as evidence against an omitted variable bias from other factors. Okay, so from factors like systematic differences in pollution levels across places. Because of course, if they were responsible for driving our results, then they should drive our results right before the election, but also right after the election, right? Whereas if we see that jump that we see here and here, that's clear, that's evidence in favor of our identification assumption. And now, in the last couple of minutes, I'm just going to show you some results from two additional surveys. One is a monthly opinion poll run by the German public television. The other is the socioeconomic panel, a very well-established panel survey. And in each of them, you have data on political attitudes, and in the SERP also a lot of other, self-reported emotions and so on. So you have lots of useful information. And what we see here as the most important result is that on days with high air pollution, people approve less of the current government and approve more of the opposition. That's what you see in this frequent small-scale survey that is run by the public television. We look at a few other outcomes that I'm going to skip in the interest of time here, but then when we look at the socioeconomic panel, we see the exact same. And these are within-person estimates. So this is the same person getting interviewed in 1 year on a day with high and in another year on a day with low air pollution. Okay, so it's within-person estimates. And on days with higher air pollution, people approve less of the current government and more of the opposition. We also looked here at people's emotions. When we lump them together through the first principal component of those four, we can see that, yes, there is a wide confidence interval, but we tend to see a positive effect on negative emotions, as in people are more likely to express negative emotions on days with a high level of air pollution. Whereas then other results from the literature that people are more risk averse, at least with the risk aversion measures that are in the SERP, we cannot really find that. Okay, so that seems to suggest emotions are one plausible channel. Can we prove it's the only one? No, but at least we can provide suggestive evidence. Okay, so to sum up and leave enough time for questions, what we show in this piece of research is that air pollution has an effect on decision making, and we're using elections here to look at decision making in the pollution, in the population at large, and we see quite strong effects. So we see that on days with high air pollution, people are less likely to vote in favor of the incumbent parties. And we can replicate this result in two other surveys, which of course increases the confidence in our results. And we also then use some survey information to at least look into some of the channels, and we find that one plausible channel is negative emotions. Okay. The main implication, you can read into this what you want in terms of voting. I'm not sure. Obviously, one implication would be reducing air pollution is good for the incumbent. But I guess the overall lesson to be learned from that is that exposure to air pollution has effects that are not limited to very specific parts of the population, but has real effects on society at large. And so that's the main take away from this. So thank you very much for taking the time, and I'm very much looking forward to your questions.